purpose of this exercise here is to discover how you can describe lines using vectors. Now the situation that we have here is we have two ships, the blue one and the red one, and they move along certain lines. So let's have a look at the blue ship first, at the movement of the blue ship. You know that the blue ship starts at 1 p.m. and with 1 p.m. it's at the position 02, so it's here, right? Now we also know that within 1 hour it moves along the direction of this blue vector. So 1 hour later, at 2 p.m., it has moved from the starting position up here. So the new position is given by the starting position plus this direction vector. And we can continue this. So 1 hour later, now you're here, and 1 hour later, you will move up here. So we again add the direction vector. So the new position is starting position plus now 2 times, because 2 hours have passed, 2 times the direction vector. And this can be continued. So after 3 hours, we are up here. Again, starting position plus now 3 times the path or the distance it covers in 1 hour. Yeah? And you can continue this for different times. So for instance, for 4 hours, and now we have 4 times the direction vector, and for 3.5 hours, we have 3.5 times the direction vector. And probably you already see the pattern here. The pattern is that any position of the blue ship can be described by a certain equation. And what always stays the same is the starting position. We always have the same starting position. And we also always have the same direction vector. But what changes are the numbers here in between. So those indicate how many hours have passed. So in general, we can set up a general equation for that gives us the position as x, y coordinates after s hours, and this is given by this equation here. X, y is equal to the vector 02 plus s times the vector 41. This again, here is the position, starting position of the ship, and the second vector, so the vector 41, tells us the direction of the ship. So with this equation, we can describe the course of the ship along a straight line. Now at this point, I think it's worth to really take a second and make sure that we have understood this, because if you understood that, then you have basically understood the whole concept, the main concept of this topic, right? Which is about describing lines using vectors. And that's just what we did. We used vectors to describe the course of the ship. The course of the ship is given by this black line, we call it G. Now here, and we said that this line G is described by the vector 02 plus s times 41. So a starting position plus a direction, right? Now, what this really means is we can have different values for this parameter s. Let's see what happens if we plug in different values for this parameter s, right? So, for instance, let's plug in the value 1.5. Now, take a second, maybe pause the video, take a second and think which point we reach on the line by plugging in the value 1.5. Okay, let's do this together. So we have the position vector, which always stays the same, and then add 1.5 times the direction vector. So these blue vectors, we multiply it by the factor 1.5, so it gets stretched with factor 1.5. So we are up here. And the resulting vector, so the green one, that's a position vector that points to a point here on the line. Points to the point 6 3.5. So that's one point that we got by plugging in 1.5. We can plug in a different value. So let's see what we get if we plug in 0.5. In this case, well, again, we have the position vector. Now we add 1/2 times the direction vector. So we don't go up all here, but just until the middle point of it. So we will land on this point. And again, the resulting vector is a vector. So the green one is a vector that points from the origin to this point here on the line. And we can continue that. We are just going to do one more example. So let's see what we get if we plug in the value -1 now. For -1, well, again, we go up by the position vector. Now we go, instead of going into that direction, we go into the other direction. So we have -1v, and we will land here at this point. And again, the resulting vector, the green one, is a vector that points from the origin to this point here on the line. And you already see probably that by plugging in different values for s, and we can plug in any value, we will reach any point here on this line G. Now you can do just the same thing for the red chip. The red chip, we know it starts at the position 3,0 at also 1 p.m. and within 1 hour it moves in the direction here of the red vector, so it moves up here. So the new position is given by 3,0 plus 1 times 3,2. And this continues, so again 1 hour later it moves from here now up in this direction, so it's from the starting position, it's from here 2 times the direction vector that we had, and this continues again, so we get the different positions at different times, right? And also here you see that if you compare all these terms, what they have in common is, well, they all have the same starting position here, and they have the same direction. The only difference is that we have different times here. Now, again, we can summarize this into a general equation that tells us the position of the ship. And the general equation is the xy coordinate equals the vector 3, 0, which is the starting position, plus r times the vector 3, 2, which is the direction, or the distance that we cover in 1 hour. And r is just the number of hours that we have, right? So now that we are able to describe the position of the two ships mathematically, we also want to know whether the two courses intercept and whether there will be a collision between the two ships. Yeah? Now, if we want to know the point of intersection of the two ships, well, that's actually not so hard, because now we know we have equations for the position of the two ships. For the red one, we have this equation here. For the blue one, we have this equation here. Now, those give us the position of the two ships. And if we know if they will have the same position at a certain point in time, then all we have to do is we have to set these two positions equal to each other. So let's do this. So we get then this equation here. So the red ship position is equal to the blue ship's position, and we are looking for the times r and s at which this is the case. Yeah? So we have these unknowns r and s, and we need to solve these equations for r and s. Now here we are using vectors, but we can actually write this as a linear system. So looking at the top components, we have 3 plus 3r is equal to 0 plus 4s. And for the bottom components, we have 0 plus 2r is equal to 2 plus 1s. Now that's a 2 times 2 linear system. We'll see this if we simplify it a little bit by putting all variables to one side. If you put all variables to one side, it looks like this. So we clearly see that this is 2 times 2 linear system with two unknowns r and s. Now, we can solve that. You can solve that manually or use your calculator. If you do that, you will get that R is equal to 2.2 and S is equal to 2.4. Now, if you want to know the point of intersection now of the two ships, all you have to do is plugging in this value here back into the equation here, right? We know that the intersection will happen at the time 2.2 for the red ship. So if you plug this in, well, then you get the point of intersection where the red ship intersects with the course of the blue ship. And the point of the intersection in this case is 9.6, 4.4. That's the position vector of this point. You would have gotten the same result if you would have plugged in the value S into the position equation for the blue ship. You would have gotten the same result here, which is the point of intersection of the two courses. Right, but what we also see here is that R and S are not equal. And this means actually that the two ships will be at the point of intersection at different times. So the red ship will be at the point of intersection after 2.2 hours, and the blue ship will be at the point of intersection after 2.4 hours. So there will be no collision between the two ships.